Welcome to the course on risk modeling in insurance. This video covers the chain ladder method to estimate outstanding loss reserves. You will start with exploring the chain ladder method in its deterministic or algorithmic version, that is, without making any stochastic assumptions. Chain ladder starts with a runoff triangle in cumulative form, as the one you see here printed on the sheet. Recall that a cell ij in this triangle, with I indicating the row and j the column in the display, shows you the cumulative amount paid up until development period j for claims that occurred in year I. Chain ladder assumes that h to h, or development factors fj, exists such that the cumulative amount in row I development period j plus 1 equals fj times cij. Thus, this development factor fj tells you how the cumulative amount in development year j grows to the cumulative amount in development period j plus 1. The display on top of the sheet highlights the cumulative amount in period 1 in red and the cumulative amount in period 0 in blue, by means of an example. Now, a next question is then, of course, how should you calculate or estimate these development factors? The chain ladder method presents an intuitive recipe to calculate these development factors. For example, the chain ladder factor F0 describes the development of the cumulative claim amount from period 0 to development period 1. You calculate this factor as the ratio of the cumulative amounts in red and the cumulative amounts printed in blue. In mathematical notation, you find the expression as printed on the sheet, where the I in the sum runs from 1, the first occurrence period in the portfolio, to 9, which denotes the last occurrence period for which both development period 0 and 1 are observed. As such, this development factor measures how the data in blue grow to the data in red, averaged across all occurrence periods for which both development periods are observed. With the numbers in the triangle, development factor F0 is estimated here as 1.49. Now, the chain ladder method uses this development factor to predict the cumulative amount for occurrence period 10, development period 1. Here too, you will multiply the most recently observed cumulative claim amount for occurrence period 10, which is the last row shown in the triangle. You look at development period 0, and you multiply this amount with the development factor F0. The resulting estimate is printed in italics in our triangle. Now, going forward with this same type of reasoning, you will estimate the next chain ladder factor, that is F1, which captures the development from period 1 to period 2. Again, you calculate the ratio of the numbers in red and the numbers printed in blue. F1 as such measures how the cumulative paid amount in development period 1 grows to a cumulative amount paid in development period 2, again averaged across all occurrence periods for which both development periods 1 and 2 are observed. In this particular example, the chain ladder factor F1 is estimated as 1.078, and the index I used in the sums in the denominator and the numerator runs from 1 to 8. These are the occurrence periods for which both development periods 1 and 2 are observed. Now, as before, you will use this development factor to predict the missing unobserved cells in development period 2. These are printed once again in italics in the triangle shown top of the sheet. Do note that for cell 10, development period 2, you use the estimate that you calculated already for cell occurrence period 10, development period 1, and you will multiply this estimate with development factor F1. So you'll move forward with the same type of reasoning And eventually you will need to estimate the numbers in the final column of the triangle. Development factor F8 measures the growth from development period 8 to development period 9 in the run-off triangle. But only the first row, the first occurrence row in the triangle, has both cells observed. Thus, chain ladder factor F8 is estimated as the ratio of the number in red and the number in blue. It is equal to 1.001 in this particular example. Hence, the cash flows paid in the final development period are minor. All chain ladder development factors, F0 until F8, are now calculated and their values are printed in the bottom row of the display printed on this sheet. The numbers in italics show the estimates for the cumulative claim amounts in the lower triangle. You get these from the cumulative claim numbers as observed so far. Do note that the most recent calendar year in this setting connects cell row number 10, development period 0, with cell row number 1, development period 9, in the display as it is shown here. You will multiply these numbers on the most recently observed diagonal with the estimated chain ladder factors. Please verify the mathematical notation for these chain ladder calculations as they are printed on the sheet. The numbers in the last column show the estimates that we obtain with this chain ladder method for the ultimate claim amounts. If you take the difference between the ultimate claim amount and the observed cumulative claim amount on the most recently observed diagonal, then you'll get an estimate for the outstanding claim amount for a particular occurrence period. This is then the chain ladder estimate for the reserve that is necessary to fulfill future liabilities with respect to claims that occurred in this particular occurrence period. Now, as a summary, the table printed here lists per occurrence period, lists per occurrence period, and for the total summed over all occurrence periods, the following items. You have first the cumulative claim amount as observed on the most recent diagonal. Then you have the development to date, which is expressed, or which is the ratio of the cumulative amount observed so far and the estimate of the ultimate cumulative claim amount. So it measures, it expresses how much of this estimate of the ultimate claim amount has been paid so far, has been paid up until the moment of evaluation. The next column displays the chain ladder estimate of the ultimate claim, cumulative claim amount, and then the last column shows you the reserve. That's the difference between the ultimate cumulative claim amount and the cumulative claim amount observed so far. Okay. Note that you will use head notation for the last two columns, as these numbers are estimates that we obtain with the chain ladder method. R's chain ladder package is used in the computer lab for these chain ladder type calculations. A standard display obtained with this R package is shown here. So each line in this visual displays or refers to an occurrence period in the upper triangle. The horizontal axis shows the development periods labeled here from 1 to 10, where 1 denotes the first observed development period and 10 the last. The vertical axis shows you the cumulative claim amounts. As you can see, for the first occurrence period, displayed in black here and labeled with a 1, all 10 development periods are observed. Whereas for later occurrence periods, for instance, occurrence period number 8, printed in red, only few development periods are observed. This picture visualizes the upper triangle in cumulative form and is used, it's the triangle that is used as input data for the chain ladder calculations. Now the display that you see here shows you some standard output that is produced by R's chain ladder package. On the top row, you see on the left-hand side the cumulative amounts paid so far, denoted here or visualized here with black bars. And then you see the chain ladder estimate of the ultimate amount, where gray bars indicate what comes on top of what has been observed so far. So these gray bars display the outstanding reserve per occurrence or per origin period. The plot also shows you a +/- standard error corresponding to the reserve estimate. And these errors are calculated with max distribution free chain ladder method, as we will explain further on. The top row right hand side has the visual has the same structure as the display on the previous sheet. But now the development is completed until the last observed period using the chain ladder estimates for the future development periods. The other plots in this display are so-called residual plots. Indeed, using the chain ladder reasoning, you can also calculate an estimate for cells in the upper triangle instead of the lower triangle, as we've been doing so far. And these estimates for the upper triangle are obtained as follows. You will start with the cells on the most recent diagonal observed in your upper triangle. You divide each cell on the diagonal by the applicable chain ladder factor, and you calculate backwards. As such, you'll get an estimate obtained along the chain ladder type of reasoning for the cells in the upper triangle. Residuals are then calculated as the difference between the observed values in the cell and its estimate. Standardized residuals are plotted here against, for instance, the corresponding observed values, the occurrence period, the calendar period, and the development period. These residual plots allow you to detect unusual observations. They also allow you to detect any remaining trends in the data which were not picked up, which were not captured by the chain ladder model. So this concludes the video on the basic chain ladder method for loss reserving.